Okay, guys, now let's see how to make use of modules. Modules.py. Okay, you have different modules. Modules that exist. For instance, modules that can be found globally. So you don't have to install them whatsoever. So you can say import and math. So I'm now importing the math module, as you can see. So how do I know the available sub-modules or functions in here in the math module? So I have this built-in function, the dir. The dir allows me to know the available modules, submodules in the math module. So just print out and then you will see the available. Oh yeah, as you can see, the one you see with 2 underscores, just ignore that because it is found in every module, but the rest is actually specific for this, the math module. Okay, as you can see, equals h assign, that's related to trigonometry, and then this seal to actually round to up, combine, and the different modules. So I will show you how to use some of the functions here from this module. So, okay, how do I access? Do I have to print this now and then? No, I don't have to. Maybe I can say print math dot square root of 4. What is the square root of 4? I think everybody knows the square root of 4. Yeah, it's 2. Yeah, I know. Print math square root of, what's the square root of 9? 3, everybody knows. But maybe I think let's make it a bit difficult. Print math, what's the square root of, 2? It's a kind of 1.4 something. Yeah, 1.4 something. It's hard. So we have to make use of the math module. Now it's easy to to calculate square root without this. For instance, I can use 2 to the power of 0.5 gives me the same value. As you can see, it gives me the same value. Or I can say print 100 the power of 0.5 means actually it's again the power, the square root. So I can do the same. Yeah, you can do the same, but there are other modules. For instance, you can access the pi, print math.pi. Yeah, I think it doesn't have. So I can, it's like this. I can access, as you can see, the pi value like this. And even you can also, the natural number, e, I think it's just e. Let's access that also. Do you remember this 2.7, the natural number we use in print math tau? There's some tau numbers. So you can access quite a lot of things. How about print.mat round? Do I have round here? Now I forgot how do I know if round is there or not? So I have to go, I print it out, if you remember, and check if we have a round method there or not. So as you can see, the modules are actually arranged alphabetically, and I don't see the round. That's why I usually say to my students, don't try to remember everything. Yeah, so because there's quite a lot. Yeah, but remember the basic and the most important. Print math.floor. Yeah, floor is actually, if I try to round 8.1, what do you think the value here? Floor, it says floor, down. It's a very greedy kind of, yeah, it's going to be 9. It's very greedy kind of rounding. As you can see, it goes all the way down. It should have been this 10. So if you want a proper rounding, a fair way of round, you can see just use round. Round is available as in a built-in function. So you can say 9.81. And if you round this, I should get just 10. This round is not from the math module, but it's just available there as a built-in function. So you can make use. Can we pass actually an argument? Yes. For instance, 1. So that means 1 significant digit. I don't care about this one, but this. So let's see. 9.8. How about if this is 5? Let us see what this will be. Is it going to be 9.9? Nope. But if I change this to 6, the result will be 9.9. Oh yeah, so it's a kind of fair approximation. Have you seen the difference, guys? If you actively following me, by now you should see what I'm doing. Or am I just enjoying what I do here? Just type something. If you are following, just type 1 for me, and then I know if you are actively following or not. Okay, good, good, great. Now there's also this floor, print mat.floor. No, sorry, not floor, ceiling. Ceiling, 3.14. This ceiling is very generous, a very kind of generous approximation or rounding up. It round up, this round down. So what do you think the value of this? Rounding up. Yes, it's going to be 4. Great. Now you know how to use this module from this. But now the main important of this lesson is not all about how to use the available math module, but how to import them. Now I'm just importing the whole math module like this, and then I am using math dot. Writing the dot might be boring, right? So we can say from math import square root pi e tau floor seal. We can import it like this actually. And then now I can remove this. And let's see again if it works. Seal, it's not, it's like this. Okay. Is it working? Yeah, it's working again. So I don't have to say math dot, because when I say from math, go to the math module and import one by one. Is it clear? Okay, can we change the name? For instance, I can change this as square root. Even we can rename it floor ceiling as round down. So I have to go this and change the name now, as you can see, square root, and ceiling, instead of ceiling, I change it to round. Not everywhere. I have to just change only here. Round down. Does it work? Of course, it should work. Even you can rename it if you don't like the name. For instance, SQRT might not be clear for people. In case if you want to rename it, it's also possible to rename it, giving it the name you want. Yep. Okay, another and very lazy way of also importing, I will show you this.
How do you rename it?
Yes, I did.
I'm saying how you said you can rename it instead of a square to rename it.
Yeah. So what's the question?
So how do you do it?
Oh, okay. For instance, this is the default method.
Yes.
So I gave it this using the word as.
Okay.
This is as. This, I didn't change this one. It was like that. Floor is also like that, but ceiling to round down. If you want this one also pi, for instance, maybe as pi. And so I have to change it to pi, for instance. Is it clear?
Yes, thank you.
Yes. If I as natural number, I call it for some reason natural, not natural number. Actually, it has got a name, but it doesn't matter. Just let's keep it like. I hope you got how to rename it. So you can rename all but one. And now I will show you also how to do it differently. For instance, instead of importing one by one, you can just import it the lazy way like this. This means, hey, go to math module and import everything what the math module has. Oh yeah. So now you don't have to think about, so just you can, but this is not very recommended way because one, you are importing everything, and it's better to just import one by one. Square root pi, like this, e, tau, and floor, what you have, okay?
What's the reason? So if you're gonna, because if you're gonna import everything, they might gonna contradict each other while you're doing something.
No need to import everything like this, like why there is no need to import the whole module. There might be some modules you don't need here because a module usually has quite a lot of other sub modules or methods. And second, it will be like a bit confusing to read your code. You don't know where this is coming from sometimes. But if you see it like you feel that it's coming actually from here. So it's easy for readability purpose also. Great. Now we learned the difference between when we say what does that mean math, and we learn also from math import one by one each module, right? For instance, square root, and floor, cell. These are very important. We learn this, and we learn also this. So this is the difference. Importing also this everything. But in this case, we have to say math dot. Is that? But this one by one. If you import like this, math dot is not, you can't say math dot here. And here also you can't say math dot. Math is not available here because you imported it as submodules. Great. Now, if we learn here how to import, how do we import our own code? Okay, then let me just create functions. Okay. I may create some functions, functions.py, okay? Make, do you know this def make square? By now, everybody knows this. And I can return. And do you know the purpose of this? I think you know, so I don't have to explain. Let's add another. Add two nums and b, and let's return a class b. Yeah. And let's def print full name. And you know that the purpose of this Is it good to make your function as little as possible and and also to make it to work for one purpose? Is it good, or what do you think? Yes, it's good because it's easy to test and it's easy to reuse because it has one purpose. Last name. Maybe you guys who are testers, you may understand what I'm talking about. First name, class. The others, you will find it at some point. Okay, so how many functions do I have here? I want you to tell me. Please tell me how many. Yes, great. Can I import this somewhere? Let's go to the modules. And now it seems time to import our own function. So I can comment this out because no need to. Yes. How do I import my function? My functions from here, some functions. Import some functions. I'm just importing some functions like this. That's good enough. So how do I know the methods or the functions I have here? Do you remember how I showed you? Print, dir. Of course, I know what I have, but no, sorry. Dir, and then just pass some function. What? Some functions. I think I need an additional. I'm well, what keyboard am I using now? Oh, why it's changed by itself? Wait. Yeah, okay. Okay, let's see. Have you seen? I told you that the you see they occur in every functions, but are you familiar with this? Yeah. Aren't you familiar with these functions? We have just created them here. Yeah. So that means we can access them. Now let's just comment out if I say print some functions dot add two nums, and I can say 1 and 2, and the value is going to be, of course, 3. I am accessing this function on this file, on the modules file. And then again, print some functions dot make square. Make square, I can say, what's the square of 10? I think everybody knows it's 100. Oh, yeah. Then print some function dot print full name. And if I say and last, maybe I can just pass it like this. It should be like this. Oh, yeah. But I told you that importing like this dot, it might not be something you like. So you can say from some functions, import one by one. So what do we have here? Add two, make square, and print full name. And now let's remove this. Yep. Great. And if you don't like this name, you can rename it. For instance, print full name, maybe if you don't like, as in a full name, you can change it and you can use it full name. I'm just showing you an example. I think this is what you need to know related to modules. So what did we do? We created different functions and we imported them in another file. How did we import? Either using import and the file name, or from the file name, import the sub modules one by one, or using star everything. That is how you do. Do you have any question, guys?
I would like to know which one is more efficient to take each particular function of that. But I don't know what, I'm not too good with the names. Meaning to say like to take each one or just take everything at once, or
this one is good. This one by one, or this. From some functions, import one by one. That's good. In that case.
So that way you don't have to write the dot every time.
Yeah, you don't have to write the dot. In addition, it's also easy to see where this is coming from. So you can see, yeah. Yeah, this is what I recommend. From starting, you can just say from and the name of the function, and then import the modules you have there. And even renaming is not very good. It's better to use the default. But in case, if you are really sure about, and if you are just a ninja, very proud of what you do, rename it. Okay. But it's better to just use what you have there. What in this case, even no need to rename it, because instead of renaming it here, what if making it a proper name here, right?
Yes.
That's more reasonable. Yes. Let's see, guys, what we have on the table. So this is the material you should follow. We have covered loops, functions, and even modules, list comprehension. Today, I can teach higher order functions, but I think it would be too much for you. Next week, you should expect higher order functions in functional programming. We will learn about that. And maybe just also to follow Elmonit. And let me show you. Yeah, so I follow this. Even then list comprehension, we have covered functions, and then next week higher order function, functional programming, and object-oriented programming would be part of this. So, and even if we get time, we may see fetching data because it can go with anything. It doesn't need any kind of order. Do you have any question, guys?
How do you get at? I saw all the list of the stuff that you showed. What we're going to learn. Is there any way I can read it also, or is this something that you have on your computer just for you?
You can read it. So are you on the Telegram?
Yes, I am.
Okay, let me just Python, because I will share there, and today's recording will be also shared there. So if you have a plan to revise it, to go through, I will be sharing it on the group. So, and even the code will be here. Now I will push it here. And now, for instance, I'm done with everything I'm doing. And so you will have here. Oh, let's add git. First, let's git status. Yeah, git add. And then git commit week-2. So what is all this? It seems there are quite a lot of codes uncommitted. Why? It seems it's yeah, it has been already pushed. It's a bit strange. I didn't push it. Git push. Yeah, I have pushed it, and let's see. And Yeah, but as you can see, it's not very good. I should have structured what I have done today. It would have been much better if we have a separate folder. I should have done it when I was starting, but I can restructure it again because I know what I have done today. So in that case, as you can see, now I had to move this here. Here's the compression. And if you want to check the codes, so it's easy to know at what week. So let's see it again. Its status, commit week to topics. And then what? Right there. Yeah, git push. Okay, now let's see if we have everything over here. Yeah, I would say we have everything over here. And whenever you want to see, yeah, have you seen? So you don't have to, even if you don't want to watch the videos, at least you can see the codes, the code we write over here. Yes.
Thank you.